All right, today we have 13.1. We will be finding the area between two curves or the area between two functions. Okay. So first page is all definition. It goes over the cases we're going to use to find this area. So by definition, if f and g are continuous and function f is greater than or equal to g of x over some interval a, b, then the area bounded by f of x and g of x on this interval a, b will be given exactly by this formula. The area between f and g is going to be the area under f minus the area under g. And it's going to look something like this. The integral from a to b of f of x minus g of x dx. Okay. Now we have three cases for finding this area underneath the curves. Case one deals with f of x being greater than g of x. So case one says that function f is greater than function g, or to keep it even simpler, case one says that function f is above function g, which is represented by the picture below. Here's f of x, here's g of x. We see that f is above g, and we want to find the area between them on the interval a to b. So if we have a case one, this means the formula is given by the integral from a to b of f of x minus g of x dx. So that's case one. If f is above g, we use case one. Case two is if f is below g, if f is less than g on the interval ab. So if f, here's function f, here's function g. So now if f is below g, or we can even say if g is above f, then the integral we will use is the integral from a to b of g of x minus f of x dx. Okay, so that's case two. And then case three says we have an interval from a to c. So this means that on this interval, we will see that f of x is going to be greater than g of x. So let's say that here's my function, not g, sorry. Here's going to be f of x. And this horizontal line is g of x. So from a to b, we see that function f is above function g. And then from b to c, we see that g of x is above f of x. So if this happens, then this is going to be a case three, where the integral to find the area is going to be the integral from a to b of f of x minus g of x plus the integral from b to c of g of x minus f of x. So we will explore all three cases today. So we'll put these definitions to use. All right, get rid of that. And I'll get rid of that and that. I'll leave that there. Okay, cool. And that should look more like an X. All right, so let's get started. And of course, we'll use Desmos today because we have to sketch the graphs in order to see the area, and we can plug the integrals into Desmos. Okay, so example one. Find the area bounded by y equals negative x squared plus 20 and y equals 0 on the interval -3 to 3. The first thing we're going to do is sketch a graph of both functions on the given interval. So that is our first step. So we're going to say step A. So I'm going to put the function here, y equals negative x squared plus 20. And I'm going to set up a nice little XY chart. And they are giving us the x values to choose already. They're saying use the numbers from -3 to 3. So we'll go -3, -2, -1, 0, 1, 2, and 3. And then let's go ahead and use Desmos. Why not? So put that there, I'll have that there. And I'm going to type in this function, negative x squared plus 20. I'm going to use the XY chart feature. And here we'll enter in our values, -3, -2, -1, 0, 1, 2, and 3. Okay. So for my XY chart over here on the notes, we get 11, 16, 19, 20, 19, 16, and 11. Okay. The other function given here was y equals 0. So we'll make an XY chart for that. So for y equals 0, here's our XY chart. And again, -3, -2, -1, 0, 1, 2, 3. But no matter the x value, the y is always going to be 0. Okay. We have our coordinates. We have our XY chart. So now let's go ahead and graph. And again, we're using that interval above, -3 to 3. So let me go ahead and make my intervals appropriate. Here is -3, -2, -1, 0, 1, 2, 3. And the highest I go is 20. So for my y values, I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay. So let's go ahead and plot the x squared function. And at -3, I'm at 11. So that'll be somewhere around there. -2, we're at 16, right there. -1, I'm at 19, in between there. And then 20, 19, 16, and 11. So here is -x squared plus 20 on the interval -3 to 3. And we're just going to call this one f of x. Okay. And now let's graph the other function, y equals 0 from -3 to 3. Well, here's 0 to, so on -3, we go 0 and 0, and it's just a horizontal line. If I could draw a horizontal line. And here is g of x.
Case 1.
And now what we want to do is find the area between these two functions. So we're trying to find the area in between these two, which means we can now move on to step B, which means step B, all we want to know is what case is this? So for step B, we see that from our graph, f of x is above g of x, which means that this is going to be a case 1. And the setup for case 1 was the integral from a to b of f of x minus g of x dx. So step B is all about finding the case, which means we will move on to step C, and we find the area by setting up our integrals. So C, it's going to be the integral on the interval -3 to 3 of f of x, which is going to be -x squared plus 20 minus g of x, which is just 0. And here, clean it up, we'll get the integral from -3 to 3 of just negative x squared plus 20 with respect to x. And we don't even have to find the antiderivative this time. Just take that integral and type it in Desmos or your calculator. So we'll do the integral, negative 3 to 3 of negative x squared plus 20 with respect to x. And we're going to get that the area between both of those curves is 102. And that's it. Any questions on that process?
So whenever we get to that part C, all we need to do is just punch it into Desmos pretty much and just get the answer. We don't have to solve it all like, by pencil, right?
Oh, did I do? There we go. Sorry, were you talking? I couldn't hear anything.
Oh, yeah, I was just
There you
saying, so when we get to part C, all we need to do is punch it into Desmos then. We don't have to actually like pencil it all out, right?
That's it.
All right, cool.
Yep. Yeah, there's this little switch on my headset that if it's up, I don't hear anybody talking. All right.
Got you. Oh, no problem.
There you go. Yeah. Okay. So again, if you want to go more in depth to this, which we don't have to, but just understand what's going on. When you're finding the area underneath or in between two curves, you're actually finding the sum of the area of a finite amount of rectangles. So underneath this curve, I can make multiple rectangles. And believe it or not, if you found the area of all these rectangles, it would approximately be what we found, 102. But again, that's just what we're doing here. But for you guys, we're just punching it in the calculator. There we go. Okay. Next. Example 2. Find the area bounded by y equals negative 4x minus 6 and y equals 0 for the interval negative 1 to 2. So again, let's go ahead and graph these, make our XY charts, and find out what case it is. All right. So negative 4x minus 6. So step A, y equals negative 4x minus 6. And here's my XY chart. And we're going from negative 1 to 2. So negative 1, 0, 1, 2. All right. And now type this function in Desmos, negative 4x minus 6. Use my XY chart, and those numbers are there already. Look at that. Negative 1, 0, 1, 2. So we're going to get negative 2, negative 6, negative 10, and negative 14. And then again, the other function is y equals 0. So for that XY chart again, you have negative 1, 0, 1, 2, and you'll get 0, 0, 0, 0. So let's go ahead and graph this function. All right. So here's negative 1, 0, 1, 2. And then looking at my y values, we go down to negative 14. So I will make the x values here go down by 2's. Negative 2, 4, 6, 8, 10, 12, 14. Negative, 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 negative. Okay. We are ready to plot. And I'll get negative 1, negative 2. Oops. which is right there, 0, -6, 1, -10, and 2, -14, right there. So here is f of x. Okay. And then g of x, which is going to be the y equals 0, is again another horizontal line from -1 to 2. And we are finding the area between these two functions. Okay, let me put that. This is g of x again. Oh, and by the way, I made an edit on the notes. That's why I send them out over the email, because I cut this lesson down by a lot of time and I made the problems a lot easier. So you're welcome.
Okay, thank you.
Because if you saw the actual lecture I did for this before, it's actually 2 videos. So now it's not so long. All right, B, just finding out what case it is. So looking at our graph, we see that g of x is above f of x. So g of x is above f of x, which means this is a case 2. And the setup for case 2 is the integral from a to b of g of x minus f of x dx. So now we're dealing with a case 2. So that means we can move on to step C, set up our integral. We're going to get the integral from -1 to 2 of 0 minus, so g of x is 0, and now we're going to plug in f of x. But be careful here. Make sure to put f of x in parentheses. So parentheses, -4x minus 6 dx. And the reason for that is this negative has to distribute. Okay. So clean it up, and we're left with the integral from -1 to 2 of +4x plus 6 dx. And now Desmos for the win again. Let's type in that integral. -1 to 2 of 4x plus 6 dx. And we get that the area between both of those functions is 24. Cool. All right. Any questions on that one?
Is there really any point in writing out the 0 if you know you're not going to even use it? You're going to just distribute it the minus.
Trust me, you're gonna want it there, because then if you don't have it there, you're gonna have the integral of, you're gonna rewrite it as the integral of negative minus 4x minus 6, which may not make sense to you when you look at it. So you need that 0 there because that is part of the function. But then when you move to the next step, we don't need that 0 anymore.
Yeah, we're just going to move over that minus sign. That's going to convert the 4x to a
Exactly. But I recommend leaving the 0 in there. Don't skip anything, because then you're going to look at it and be like, what did I do?
Yeah, for sure. Okay.
So let's
All
say
right.
if that 0 was like a 2,
Mhm.
we would multiply.
Well, if it was the integral and it was 2, like 2 minus, now my pen doesn't want to write. It was like 2 minus 4x plus 6, then you would distribute that negative and you would have 2 minus 4x minus 6, and then you would combine these two, and then eventually you'd get the integral of -4x minus 4. So if it was a number other than 0, then you would combine like terms.
Okay,
Oh,
so
I'm sorry. I thought you were like multiplying like FOIL.
Oh, no. You only multiply if, so remember, if it's 2
That's what
minus 4x plus 6, that negative goes in there. But if it's 2 times 4x plus 6, then you distribute the 2. See the difference?
No, explain again. I'm sorry.
So if it's 2 minus, the only thing that gets distributed is the negative.
Oh, okay. I got you.
If it's 2 times, then you would distribute the 2.
Okay, so like it. Okay, yeah, I confused. I'm sorry, because if the minus was in front of the 2, it would still FOIL. I just got confused.
Exactly. You'd still distribute it. Yeah. If this was -2, then yes, you would still distribute the -2. All right. Cool. Okay. Next. Find the area bounded by -3x and 0. So f of x equals -3x, g of x equals 0 on the interval -3 to 2. Okay. So once again, XY charts for both of them. So here we have A, and f of x equals -3x. And then make my XY chart. And here we go from -3 to 2. So -3, -2, -1, 0, 1, 2. And we don't even need Desmos for this one because you just plug all these numbers in for x and multiply them by -3. All right.
What?
Still going. All right. And you get
What?
0, -3, -6. All right. Cool. And then for the other one, for g of x equals 0, it's going to be the same as the other ones. For x and y, for -3, -2, -1, 0, 1, 2, no matter what, the y value is always 0. Okay. Now let's make our intervals appropriate. And -3 to 2. So -3, -2, -1, 0, 1, 2. And the highest we go is 9. We're going by 3s. And the lowest we go is -6. Cool. I could go by 3s. Sure. It'll save time. 3, 6, 9, and then -3, -6. So for our graph, it's -3, 9, -2, 6, -1, 3, 0, 0, 1, -3, and 2, -6. Here is f of x. And then g of x is again the horizontal line from -3 to 2. And there's g of x. Okay. Zoom in a bit here so we can see what we're working with. We need to find the area between f and g over here. And then we need to find the area between g and f over here. So I'll just label it for us.
Gonna be a case 3, ain't it?
Exactly. So for this interval, on -3 to 0, f of x is greater than g of x. And then on this interval, on 0 to 2, g of x is greater than f of x. So based on what I wrote on our graph, we know that this will be a case 3. So for B, we know it's a case 3. Okay. And the setup for a case 3 is going to be the integral from a to b of f of x minus g of x dx plus the integral from b to c of g of x minus f of x dx. Okay, so we are ready to go. Move on to step C. Okay, so we're going to have the integral from -3 to 0 of f of x minus g of x dx plus the integral from 0 to 2 of g of x minus f of x. Dx. Okay, just a little cleanup and we'll punch it in. This is going to be the integral from -3 to 0 of -3x dx plus the integral from 0 to 2 of positive 3x dx. And now this last integral is what we're going to type in our calculator. All right. Okay, so we're going to go the integral from -3 to 0 of -3x dx plus the integral from 0 to 2 of 3x dx. And the area between both of those curves, both of those functions, is going to be 19.5. And there we go.
I have a question.
What's up?
Where did you get the A, the B, and the C from?
That is from the definition.
Okay, let me go back to that to reread it.
So look at that. So if it's a case 3, the interval now changes from A to C because on this new interval, we have f of x being greater than g of x and then g of x being greater than f of x. So you see all of this right here?
Okay, it's because mine's kind of faded. Sorry, I can't read it too well.
There you
My
go.
print, that sucked. Okay, so f of x minus g of x, d of x plus. Okay.
So you see the intervals, A to B, and then B to C.
The B to
right.
C part, I think, is like what's not clicking for me. The A to B, that, I mean,
Yeah, so A to B is the interval we were working with. So I guess we could just use this for example, right? So let's say for that last one, it was, the interval was -3 to 2, right? So
okay.
here's -3, here's 2. But now we have a value in between where it changes from f of x being greater than g of x to where g of x is now greater than f of x. So this was considered our 0. So now it's broken into multiple intervals. So this would be from -3 to 0 and then 0 to 2. That's it.
Okay, and then to determine, I guess, what the B is, like, is it just by looking at it?
Yeah, that's it. Because now this is A to B, and now that's B to C.
Okay, okay, okay. All right.
All right. All right. All right. All right. Cool. Okay. Dun, dun. So those are 3 examples, and now we'll do a word problem. Yeehaw. All right. Using production and geological data, the management of an oil company estimates that oil will be pumped from a producing field at a rate given by the function R of T equals 100 over T plus 10 plus 10 and the domain for this function is 0 to 15. Okay, where R of T is the rate of production in thousands of barrels per year, T years after pumping begins. Find the area between the graph of R and the T axis. So you can replace T with X. They both mean the same thing. Here they're using the variable T. Over the interval 5 to 10 and interpret the results. Okay, so just like the last one, make our XY charts for both functions, graph it, find the case, set up the integral. Okay, but if you're using your calculator or Desmos, we're not going to use T, we're going to use X. If you put T in here, it's going to ask you something crazy. So just stick with X. I'll even write that down here, why not? Okay. So A, we'll change this to R of X equals 100 over X plus 10 plus 10. And now we'll make my XY chart. And they gave us an actual new interval to work with. They want us to find both of these functions over the interval 5 to 10. So that's what we're working with. So that means here, it's going to be 5, 6, 7, 8, 9, 10. Okay, and I'm going to type this in Desmos. X plus 10. Nope, sorry, wrong way to go. 100 over X plus 10 plus 10. Do my table feature and type these values in 5, 6, 7, 8, 9, 10. And here I get 16.67, 16.25, 15.88, 15.56, 15.26, and 15. There we go. And lucky for us, the other function is once again y equals 0. Lucky us. And don't worry, your homework should be exactly like that. No ringers. I made this easy for you guys. So that means, again, for our
Thank you so
XY
much.
chart, you are welcome. For our XY chart, we say no matter what X value we pick, Y is always going to be 0. So let's just sum this up and say that 5 and 10 is still going to be 0, 0. Any number in between there, the Y value will still be 0. Okay. Now let's go ahead and make our graph appropriate. We're going from 5 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the highest we go is 16.67. The lowest we go is 15. So I could do this by 2s maybe. Go by 3s. And again, it's just a sketch. It doesn't have to be perfect. Let me go by twos, sure. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. That's all we need for that. And now let me graph the first function. So I get 5 and 16.66. So I'm just going to put that around here somewhere. Around here, sure. And then 6 is 16.25, still above 16. 7 will go below. And then 8, a little lower, 15.55. 9, 15.26, get in there, and 10, we're exactly at 15, so right there in the middle. Okay, so if we look at the graph on the left, it's definitely way more curvy than mine's gonna be. But again, this is just a sketch. So we should look something like this, just a little curve. Okay, and then once again, lucky us. Here's the next function. It's another horizontal line from 5 to 10. And we are finding the area between these two functions. So now this is going to be considered R, well, we made it R of X, R of T, R of X. And now this is our, we'll call it G of X, sure. Okay. So by our graph, we see that R of X is above G of X. So what case is this?
1.
Case 1. So B, this is where R of X is above G of X. So this is case 1. And we know that setup already. We've done it before. So we can just move on to C. And we'll get the integral from 5 to 10 of 100 over x plus 10 plus 10 minus 0 dx. Okay. And now I'll just type it in because we don't even have to worry about that 0 now. So on Desmos, I'll type this integral in from 5 to 10 of fraction 100 over x plus 10 plus 10. Close parentheses with respect to x, and we get 78.76. Okay. But of course, we want to interpret our results. So based on this problem, it says that R of T is the rate of production in thousands of barrels per year, T years after pumping begins. Find the area between the graph of both functions on the interval 5 to 10 and interpret the results. Okay. So what we're saying is that in between 5 and 10 years, we are going to produce 78.76 barrels. But remember that this number must be in the what?
Thousands.
Thousands. So for our answer, we're not creating 78 barrels. We need to multiply this by 1,000. And we are actually creating, what is that? 78,000. 78.76 times 1,000. Yeah, we are creating 78,760 barrels between that time period. So you'll have a question exactly like this on your homework. And the very last one is going to ask you, how many thousands of barrels are you producing between this time interval? And you must remember that it has to be in the thousands. Okay. Any questions on that one? Doesn't Desmos make your life easier?
Sure does.
Okay, so those are the examples for area between two curves. And we'll get into one last definition here called the Lorenz curve. And it's actually pretty cool. It talks about income equality and inequality in certain groups, certain countries, anything like that. So by definition, the Lorenz curve is the method used by economists to study the distribution of income in a society. The Lorenz curve is found by using regression analysis, a technique for fitting a function to a data set over a given interval. X represents families at or above a given income level, and Y represents the cumulative percentage of total family income received. So if you look at these graphs, we have the line Y equals X. This is called the curve of absolute equality. So the closer that the Lorenz curve gets to the curve of absolute equality means that in one population, income is close to getting equally distributed. This means that we are all making the same amount of money, which will never happen. But if it ever touches that line, that means income is being equally distributed. The further you get away from the curve of absolute equality, so let's say that this curve filled out the whole triangle, right? Let's say that that curve filled out the whole triangle. This means that income is unequally distributed and the money is in the hands of one part of the population. So somebody's making all the money and we're making nothing. So this is what the Lorenz curve does. All right. So absolute equality. So this is just what I said. Absolute equality of income would occur if the area between the Lorenz curve and Y equals X were 0. So this means if they were both touching. This means that income is getting more equally distributed. It's absolute inequality if the area between the Lorenz curve and Y equals X reaches 1/2, which actually becomes the area of the triangle. So it fills out the triangle. And this means all the money is in the hands of one group, one family, one person. Okay. So to represent the ratios between the areas, we use something called the Gini Index. And this is given by the formula 2 times the integral from 0 to 1 of x minus f of x dx. So this is also finding the area between two curves, which is pretty cool. The Gini index is a number between 0 and 1. The closer you are to 0, the more income is being equally distributed. The closer you are to 1, the more income is unequally distributed. And the Gini index is used to compare income distribution at various points in time between groups of people, before and after taxes, different countries, on and on and on. So let's go ahead and work the last example using the Gini index. Okay, 5. The Lorenz curve for the distribution of income in a certain country in 2013 is given by f of x equals x to the 2.6. Economists predict that the Lorenz curve for the country in the year 2025 will be given by g of x equals x to the 1.8. Find the Gini index for both years. Okay, so let's go ahead and find the Gini index for 2013, find the Gini index for 2025, and interpret the results. All right. So for 2013, all right. So for A, we get, let's say, the Gini index, and we get 2 times the integral from 0 to 1 of x minus our function here. And our function given is x to the 2.6. So you get x minus x to the 2.6 dx. And all we have to do now is just punch this in the calculator. So looking at Desmos over here, I get the integral, oh, don't forget that 2 in front, 2 times the integral from 0 to 1 of x minus x to the 2.6 dx. And we get 0.44. So the Gini index for this population in 2013 is 0.44. Okay. And now let's go ahead and do the same for 2025. So for B, we get the Gini index is going to be 2 times the integral from 0 to 1 of x minus, and here we're given x to the 1.8 dx. Plug this in, same way we did above, 2 times the integral from 0 to 1 of x minus x to the 1.8 dx. And we get that in 2025, it is predicted that this country will have a Gini index of 0.29. So remember that for the Gini index, the closer you are to 0, the more income is being equally distributed. And the closer you are to 1, the more income is being unequally distributed. So what it says to interpret the results. So what do you guys see as a difference between 2013 and 2025?
2025 is going close to 0.
So that means it's more equally distributed, the money.
Exactly.
But
So,
where is this even coming from? Is this like an actual thing?
yeah.
Huh. I'm gonna look into it later.
Yeah, definitely look it up. It's cool. So we are predicting, or whoever made up these functions, they are predicting that this certain group, this certain country in 2025, population will be, or not, the income will be more equally distributed. And in 2013, we see it's 0.44. It's a little high. It's close to half. And their income is not that equally distributed. But I would say 0.4 is still not a bad number. But if it gets better to 0.29, great.
That would be
Okay.
that'd be probably related to the census and all that, right?
Exactly. So everything can go into it. I mean, the studies could be even a small population. They can even do a study on your neighborhood, right? Like is income equally distributed in your neighborhood? It could even be with students. So it can be a study of anything. So again, look into it more. It's pretty neat. Here, we're just crunching numbers, right? All right. And that is 13.1. So we are done.